It's chemistry and you are watching Chem Science.
In this video, we'll be solving question paper 4.2 of 0620 chemistry of the examination series October-November 2022, and we have already solved question 1 to 3, and this video will be solving question 4 to question 6, that is the remaining paper. So let's go ahead. So here we start with question 4 as we have already done till question 3, and the question 4 says a student prepares magnesium sulfate crystals MgSO4 by adding excess of magnesium to dilute sulfuric acid, and the first sub question A for this question is write the chemical equation for this reaction. Now what's the reaction going on between? It's magnesium and dilute sulfuric acid. So magnesium in symbolic form plus sulfuric acid again in the symbolic form, that forms magnesium sulfate. That is also given in the question. So we are writing magnesium sulfate, and the remaining product is hydrogen gas. Now it's necessary to have a look once whether the chemical reaction is balanced or not. If we have a look, all the full chemical reaction is balanced, as magnesium is 1, on the other side also magnesium is 1, hydrogen is H2, on the product side also it's H2, and sulfate SO4 as such on both sides. So we don't need balancing this chemical equation, but it's always necessary to check, and if not balanced, do balance it, because this full balanced chemical equation carries the marks. Let's go ahead with question B. It says describe two observations which shows that the reaction has finished. Now let's read again what the question is. Student prepares magnesium sulfate crystals by adding excess magnesium to dilute sulfuric acid. Now the reaction is between excess magnesium and dilute sulfuric acid. So here we can see that one of the product is hydrogen gas. So the first observation is fizzing will be seen, but as the reaction gets over, fizzing will stop. So the first observation which tells us that the reaction has finished is fizzing stops. You can say the bubbles stops producing, or you can also say that the effervescence stops. Anything can be used instead, but here we are writing fizzing stops. The second observation is that magnesium stops dissolving. Magnesium stops dissolving, or magnesium is present in the conical flask or in the mixture. You can write anything. Here I am writing magnesium stops dissolving or stops reacting. Anything is acceptable. Magnesium stops dissolving. So here 2 marks for the 2 observations. Let's go ahead with sub question C. It says the excess magnesium is removed by filtration. State the general name given to a solid separated from a solution by filtration. So after filtration, what are we asked is a general name of the solid remaining after filtration, and the general name for the solid remaining in the filter paper is called residue. So here we write residue in the question. Let's go ahead with the D part, where D part says aqueous magnesium sulfate is heated until crystals begin to appear. Suggest the name for a solution in which no more solute can dissolve. Okay, the solution in which no more solute can dissolve is called saturated solution. That's very simple, because it's the definition of saturated solution, that the solution in which no more solute dissolves. Okay, the next subpart is suggest why more crystals of magnesium sulfate appears on cooling. On cooling, the crystals of magnesium sulfate increases. Now on cooling, what happens is the amount of water may decrease, and also happens that on decreasing the temperature, the solubility decreases, and that's why the crystals appear. So what main reason we'll write for 1 mark only. So main one reason we are supposed to write in one sentence, that is on decreasing the temperature. On decreasing the temperature, the solubility decreases. So on decreasing the temperature, solubility of any substance should decrease. So solubility decreases. That's the main answer. Okay, E sub question says magnesium sulfate crystals have the formula MgSO4.XH2O, where X is a whole number of molecules of water. Okay, the student heats the crystals to remove the molecules of water. So here is the equation where it says MgSO4.XH2O is heated to produce anhydrous magnesium sulfate and XH2O water molecules in the gas form, that is, it gets evaporated. Now the question is, name the term given to crystals containing molecules of water. Okay, like magnesium sulfate, it has the molecules of water. So what is the common name given to such salts carrying water? So that is called hydrated salts or hydrated compounds. You can even write hydrated crystals. The main part is any substance carrying water is called hydrated. Now let's go ahead with the next subpart is, so the next subpart here, it shows there is some calculation here. Let's see what's the calculation. The student heats a sample of magnesium sulfate, hydrated magnesium sulfate, and finds it has lost 0.140 moles of water and has 2.40 grams of magnesium sulfate remaining. Now here understand, one part is that the water is amount of water is given in moles, and the amount of magnesium sulfate remaining is given in mass, that is, it's given in grams. Now the question main is that determine the value of X. Use the following steps. Now calculate the molecular mass, that is relative molecular mass of magnesium sulfate. Now you can always refer the periodic table which is given at the end of the question paper. So let's go ahead. Actually I remember the atomic mass of all, but for students it's necessary to refer the periodic table for all. So let's have a look that magnesium sulfate have a mass of 24, so Mg is 24. Sulfur, you can see here it is 32, and oxygen we already know it's 16, and so we need to add up all of these masses to calculate the MR of magnesium sulfate, that is molecular mass of magnesium sulfate. So here is our question. Let's add up for magnesium sulfate. If magnesium is 24, sulfur is 32, and oxygen is 16, but that has to be multiplied by 4. And adding up all these values, we get the answer 122. So molecular mass of magnesium sulfate is 120. Now the next part is determine the number of moles of magnesium sulfate formed. Now what about magnesium sulfate? What information is given is its mass, magnesium sulfate mass. So if we want to calculate the moles from mass, we have the formula N is equal to M upon MR. So mass is 2.40, and the molecular mass we have already calculated, that is 120. So answer after division we get is 0.02. So 0.02 is the moles of magnesium sulfate which we have calculated. Okay, next is determine the value of X in MgSO4.XH2O. Now here in this formula we can see that MgSO4.XH2O, where we can see that there is a ratio of 1:X. Now this 1:X is the mole ratio of magnesium sulfate and water molecules. So if we have got both the moles of magnesium sulfate and the moles of water, which is given here as 0.140, so let's find out the ratio of both the moles of substances, that is magnesium sulfate and water. So if we find out the ratio, we need to divide both of the moles, that is 0.140 Divide by the moles of magnesium sulfate, that is 0.02. Now if we divide, we get the value as 7, and so our value of X is 7. That is, the water molecules are in the ratio of 7 compared to magnesium sulfate molecules. I hope this question is very clear. There is a simple calculation of the mole ratio of magnesium sulfate and water molecules. We calculated the moles of magnesium sulfate first and then found out the ratio of the moles of both the substances, magnesium sulfate, water, and that gave us the value of X, and that is 7. So let's go ahead with the next F part, where it says if the student uses dilute nitric acid instead of dilute sulfuric acid, the salt formed is magnesium nitrate. Write the chemical equation for the reaction when solid magnesium nitrate is heated. Now reread the question whenever you think you are not clear about what is asked. Here it says, write the chemical equation for the reaction when solid magnesium nitrate is heated. Now I have seen students getting confused at such point where they might write an equation between dilute nitric acid and magnesium forming magnesium nitrate, as we had earlier written with the sulfuric acid. But here, reread the question. I would prefer where we are told to write the heating of magnesium nitrate, and we need to write the chemical equation. So we are actually writing the thermal decomposition reaction for magnesium nitrate. That is, if magnesium nitrate is heated, what are the products formed? So the products formed are MgO plus NO2, that is nitrogen dioxide, plus oxygen. Now this is the reaction which we should know, it's in our syllabus. And now balancing, we get this mole ratio of 2:2:4:1. So this is the complete chemical equation after balancing on the thermal decomposition of solid magnesium nitrate. So let's see that what is our next sub question. I went up here. Okay, question 5 we are starting with. Question 5 says ethane is an alkane. So now we are starting with an organic question. Ethane is an alkane which undergoes a photochemical reaction with chlorine as shown, and here is the equation given where ethane is reacting with chlorine to form chloroethane and HCl gas. Write a general formula of alkane. So if we are talking about a general formula of alkanes, we are going to write CnH2n plus 2. This is the general formula of alkanes. Okay, state why this reaction is described as a photochemical reaction. Because this reaction takes place in presence of light. You can specify that it occurs in the presence of UV light also. But if we are talking about photochemical reaction, you can just end up writing with the light also. So this reaction takes place in presence of UV light. I always prefer being very specific if I know the answer. So I'm getting specified here in the presence of UV light. Okay, let's go ahead with the next subpart. It says in this reaction an atom of hydrogen is replaced with a chlorine atom. State the name of this type of organic reaction. Now let's understand what is happening in the reaction. Here it says hydrogen is replaced by chlorine atom in the ethane. So if it's a replacement reaction, for the organic reaction we will use the word substitution. So it's a substitution reaction. Organic reaction in which one atom is replaced by another atom is called a substitution reaction. Next sub question says in this reaction one of the product is chloroethane. Name the other product. So now let's have a look at the reaction again. It says one of the product is chloroethane. So chloroethane is this product. Remaining product is hydrochloric acid. But if we name it in a proper way, we can write as hydrogen chloride. Even if you write hydrochloric acid, it's fine, but what I prefer is hydrogen chloride. Why? Because here it is in form of the gas formed. We haven't dissolved this HCl gas into water to form it as an acid, so I'll just prefer writing it as hydrogen chloride. Let's see what comes up next. Here there is an energy profile diagram. Energy profile diagram of this reaction is shown here. Name the energy change labeled A. Now labeled A here is a bump above the level of the reactants, and that is called activation energy. Remember, an extra bump which is above the level of an reactants, that is called activation energy. Next it says name the energy change labeled B. Now if this is the energy difference between the reactants and products, and we call it as an enthalpy change, or we can also call it as energy change of the reaction. You can use the word enthalpy change or an change in the energy of a reaction. So change in the energy of a reaction, energy of reaction. So here we write anything is allowed, because that's B is actually denoted by delta H. State how the energy profile diagram shows this is an exothermic reaction. Now for an exothermic reaction, the energy of the product should be less than the energy of reactants. So here we simply write that energy of products, we can see that the level of the products is given below the energy of the reactant. So energy of products is lower or less, you can write lower than the energy of reactants. That's the main point which proves that it's an exothermic reaction. There is a next sub-question following, sub-question F here, and the equation for the reaction can be represented as shown. Now you can see that the same reaction is presented showing all the bonds of the molecules with the display diagram of the molecules, where ethane, chlorine is shown, chloroethane and hydrogen chloride is shown, and here you can see that some bond energy is also given. Bond energies of each bond of this reaction is given. Now here it says use the bond energies in the table to calculate the energy change in this reaction. Use the following steps. So let's see that what are the following steps here. I'll keep the energy of the reactants visible, energy of the bonds visible. Here it says calculate the energy needed to break the bonds. Now energy needed to break the bonds is the energy of the bonds on the reactant side, and on the reactant sides we can see how many bonds are there. Let's have a look again. Let's have a look and that remember that how many bonds are there. We can see that there is one CC bond which is given here. There are CH bonds 1, 2, 3, 4, 5, 6. There are 6 CH bonds here, and then there is one Cl bond there on the reactant sides, and on the product side there is one bond less of CH and one additional bond of CCl is given, and HCl bond is also added. So let's go ahead and calculate the energy of the reactants and products, where the calculate the energy needed to break the bonds is for the reactants. So as we have already seen, there is one CC bond, so 354 CC bond. Then there were 6 CH bonds, so 6 into the value of CH bond, that is 410, plus one Cl bond, that is 240, so 240 addition. So on addition of all these values, we should get 3050 kilojoules, that is 3050 kilojoules. So this is what we get for the energy needed to break the bonds, that is the energy of the reactant sides. Now the next says calculate the energy released in making the bond. So now this is the energy of the product side, where we had seen again there was one CC bond. So if there is one CC bond, then again it has to be 350 For CH bond we had seen that there was one less, so we are now multiplying the CH bond, that is 410, with 5 in place of 6 which we had done in the reactant side. One more bond is added here, is CCl bond, which is 340. So let's add this 340, and then there was hydrogen chloride as one more product. So for hydrogen chloride we'll be adding 430. So all this summing up we get 3170 kilojoules. Now this is the answer for the energy of the products. So let's write up that further in the space given, where we can write here it as 3170 kilojoules in the dash given. Now what are we going to do is determine the energy change. So here we are supposed to find out the change in the energy, that is the energy of the reactants minus the energy of the product. So this is how we find the change in the energy. So if we find out for reactants, which we have already done, this is 3050 minus 3170. So if we subtract these two values we get an answer in negative, that is 120. So our answer change in the reaction is minus 120. Now let's be specific. I like to tell you here is that the sign negative or positive is a very important. Even if it is positive, try writing positive plus in front of the value. Here we have already got a negative value, so don't forget adding the negative sign in front of the answer, that is the value of the energy change. Here is our calculation done. Let's see what is question 6 here, and question 6 says a carboxylic acid Y has a structure shown. Here is a structure of one of the carboxylic acid HCOOH. State the general formula of the carboxylic acids. Now again, as we had written for the alkanes, we are supposed to write the general formula of carboxylic acids, and it is CnH2n plus 1 instead of plus 2, which we had written in the alkanes. So plus 1 and then COOH. COOH is necessary at the end again. So this is the general formula. Name the carboxylic acid Y, which is shown here. Now in the carboxylic acid Y, we can see that there is only one carbon atom present, and any compound carrying one carbon atom is meth. And if it is carboxylic acid, it should end up with oic acid. So methanoic acid. So let me rewrite again here it as methanoic acid. Methanoic acid is the name of the carboxylic acid given in Y because it carries just one carbon atom. C part says write the molecular formula of the carboxylic acid Y. Now if we calculate the molecular formula, let's count how many carbon and hydrogen atoms are present. One carbon is present, which we have already seen. Hydrogen present are 2, 1 and 2, and oxygen present are also 2. So again O2. So molecular formula will be CH2O2. That is how we will write. Count the number of atoms of each element present and write it in general straight ways. Let's see what is our next question. Here it shows some type of dot and cross diagram. I think again it is about the methanoic acid. Complete the dot and cross diagram to show the arrangement of electrons in a molecule of carboxylic acid Y. Now this is a question of bonding which they have mixed up with the organic also, but no problem. Let's go ahead, where we can see that the carbon is presented by the dots. Now if we know that carboxylic acid is having 4 electrons in the outer shell, obviously with hydrogen it shares only 1 electron. With one more oxygen it will share 1 more electron, because in oxygen is having 6 electrons in the outer shell. It should get 2 more to become stable. So 1 from the carbon here it will get, and 1 from the hydrogen it will get. So for carbon oxygen bond here I am sharing only 1 electron. So now carbon is remaining with 2 more electrons, so that has to be shared with this oxygen, and so both the electrons goes here. Also, if you have a look at the structure which is drawn, let's see what is the structure above which is shown here. You can see that there is a double bond with CO on the top given. So double bond means 2 electron pairs being shared. So we need to share 2 pairs of electrons with one of the oxygen shown here. So that carries the double bond. Okay, all the 4 electrons of carbon is done. Now let's see about hydrogen. Hydrogen here will share 1 electron, which I am again presenting with the empty dot. Here I have done. For oxygen there should be crosses. So if 2 electrons from the carbon are shared, the same 2 electrons from the oxygen part is also shared here. So 2 of the electrons or oxygen are done with the carbon. So if oxygen have 6 electrons in the outer shell, 2 are done, so it's remaining with the 4 more electrons. So let us draw 4 crosses in the circle which is outside this sharing area. That's done. Now let's go ahead with this next oxygen atom. Again, that oxygen also will have 6 electrons in its outer shell, where 1 is shared with the carbon and 1 is shared with the hydrogen. Now again, it's remain with the 4 more electrons, so let's add that in the remaining part of the non-sharing area. Now we are left with 1 more hydrogen. Again, it's going to share 1 electron for any of the atom. That is fixed. Hydrogen can have only 1 electron, and that is shared for bonding. So only 1 electron for the hydrogen goes in the sharing. So this is how we have made a dot and cross diagram. And here is our clean and clear dot and cross diagram. I have rubbed all the extra marks which I drawn to explain you people the dot and cross diagram bonding. So here this is how it should look with very clean and clear area, dots and cross being shown very clearly. Let's see what is our next sub question E. Sub question E says carboxylic acid Y will react with propane 1-ol, that is C3H7OH, to form an ester Z and one other product. Name and draw the structure of ester Z. Show all the atoms and all the bonds and name it and draw the structure. We know that the carboxylic acid Y is methanoic acid, and the alcohol used is propanol. So while naming, we should always understand that the alcohol part is named first, which is written as propyl. So YL is added. So propanol is written as propyl in the name of the ester first, and then add the name of the acid part. So acid part is methanoic acid, which we will name as methanoate. So the name of the ester made from alcohol and acid is written as propyl methanoate, because alcohol part is always written first and then the carboxylic part by adding the names which I have shown you here. Now drawing the structure, we should always draw the acid part first. So if we are drawing an acid part first, I should draw the methanoate first, where it was asked that show all the atoms and all of the bonds present. So starting with the methanoate part, the COOH part was there, but here out of COOH, OH goes out. Let me explain you here on the side part. COOH and alcohols are presented in general like this. When an ester is formed, the OH from the carboxylic acid, and I should present it like this, and so H from the alcohol goes off, and then there is a linkage of CO and O from the alcohol and carboxylic acid. So now there is a linkage here showing the ester linkage where the carboxylic acid and alcohol is bonded. So now here, from here, this oxygen starts the alcohol part, that is propanol part. So O of the propanol is written here, and the remaining is the propanol, that is 3 carbon atoms. So here if propanol is there, I should add the remaining hydrogen to complete the structure of alcohol, and so here is the propanol part fully added. So again, let me tell you what is this. First draw the carboxylic part, which is methanoic acid in our case, which I have drawn here, and then from the O part add the alcohol by reversing it and removing out the H as I have shown here. So H is removed from the propanol and the remaining part is added, and so this is how our structure of the ester will be shown here. I have drawn it in a rough way because the bonds are not very clearly and nicely shown, but you can always draw it in a very clear way. So again, I have rubbed all the rough work which I had drawn to explain you, and this is how the structure should look clearly with all the atoms and all the bonds shown. Next sub question says, name the other product formed when carboxylic acid Y reacts with the propane 1-ol. So after the reaction between acid and alcohol, ester is formed, and remaining part, the remaining product, other product formed is here. You can see that the OH and H is removed, that will be forming water molecules. So the other product is water. Now if they have said name the other product, so we are supposed to write water, and we can't just end up writing the symbol H2O. That's not allowed because it's the name. Okay, let's see what is the next sub question, where it says name an ester which is the structural isomer of ester Z. So the first question which arises is, what is the structural isomer? Now structural isomers are the compounds which have same molecular formula, but the structure is different. Structure should be different. So here if we have drawn propyl methanoate, methyl propanoate can be another ester with the same formula, same molecular formula will be there. You can also write it as ethyl ethanoate, because again it will end up with the same number of carbon atom, oxygen atom and hydrogen atom. But here for just namesake I am writing it was propyl methanoate, so I am writing it as methyl propanoate. You can reverse the alcohol and the acid part. But I'm 100% sure if we are talking about structural isomers, even if it is not given in MS, you can still write ethyl ethanoate, because number of carbon atom, hydrogen atom and oxygen atom should remain same. Here we can see that there are 4 carbon atoms. So ethyl ethanoate will also end up with 4 carbon, 2 oxygen and remaining hydrogen. Okay, next go ahead with the next part. Here it says a carboxylic acid which is a structural isomer of ester Z. Now we are supposed to name the carboxylic acid which is having the same isomer of ester Z. Means the number of carbon atom, oxygen and hydrogen should remain same. Here we have 4 carbon atoms. Oxygen is obviously 2 if we are writing ester or carboxylic acid, and remaining hydrogen. So if we are writing a name with carboxylic acid with 4 carbon atom, then it should be butanoic acid, because our ester has 4 carbon atoms and carboxylic acid with 4 carbon atom is butanoic acid. So this is the carboxylic acid with the structural isomer of ester Z. I hope it's clear. Why am I saying butanoic acid? Because we can see that our ester had 4 carbon atoms. We can see here the structure: 4 carbon atom, 2 oxygen atom, and then there were I think 8 hydrogen atom. Yes, 8 hydrogen atom. So if we have acid with the same molecular formula, that is going to be butanoic acid. So carboxylic acid with the same number of carbon atom is butanoic acid. So here our paper gets over, which we have fully described, fully solved in 2 parts. Our earlier video have the first 3 questions, and in this video we have solved the next 3 questions. I hope all the explanation which I have given through the whole paper is very clear.